Hey there, so there's a couple of things we can do here. We could either get common denominators for the fractions. So if I wanted to combine these x's together, this one is over 5, and so I would also need to get this one over 5s to get a common denominator so that I'm able to add these. So this would be like an invisible 1x plus 5x, so that would give me 6x over 5 equals 3/10. And from there, we have this fraction, 6/5 times x. So my preferred way for solving that would just be, I could multiply both sides by 5 and then divide by 6. I think it's easier if we use the reciprocal and just do it all in one step. So I'm going to go 5 over 6, and you can see how that's going to cancel out, and 5 over 6 on this side. And now this would be 30 over 30, so that's all canceling, and I have x by itself over here. And on this side, I have, you could go ahead and write this as 15 over 60 and then reduce it from there. And 15 would be 1 times 15, and then 15 goes into 60 4 times 15. And I can knock those out and get 1/4 that way. What I think is easier is to actually do it back here, so rather than multiply, to look and see if there's anything that can be reduced before we multiply. So 3s and 6s, 3 goes into 3 once, 3 goes into 6 twice, 5s and 10s, 5s go into 5 once, 5s go into 10 twice, and then there's your 1 times 1 makes 1, your 2 times 2 makes 4. So for me, I prefer to reduce before I multiply, but if you multiply, you can still get there reducing that direction. So that would be one way. So that's the version where we don't clear the fractions. And then this next one, I think it's maybe a little more confusing to get your brain around initially, but then it ends up with easier math. So the first step is harder, and then it's easier after that. So if we wanted to clear the fractions, and we're allowed to do that because we have an equal sign, which means I can multiply everything by some value, and as long as I do it to both sides. So I'm going to think of that as over 1. What I want to do is multiply each of these fractions by the lowest common denominator, because that's going to let me reduce out and then not have fractions. So 5 and 10, they both go into 10, so that's my LCD in this case. So here, and let me write out the step, and then I'll shortcut it after I write it out so I can point at it. So let me start here at 10 times x over 5, and I'll make that a 2 in just a second. 10 times x right there would give me 10x over a 1. That doesn't really matter. And this side, again, these 10s would cancel, but I'll write it as 3 times 10 over 10, just so I can kind of show you the canceling. So here, 5 goes into 10 twice, so that's really just a 2x. So if I'm doing this without this line, which I would suggest to try, then 5 goes into 10 twice in that case, and you're just going to have a 2x there. You'd have to be careful that you make sure that you get that 10 multiplied to this term as well. So then that would be 10x right there. Those cancel, and I'm left with 3 on this side. And so just to kind of recap that, let me get rid of this and that I did, and that, and that. So here, if I'm thinking of doing this without writing all this out, and if it helps to write this out, do it, but for me, I would just think 5 goes into 10 twice, so that's going to be a 2x, 10 times x, there's 10x, 10s cancel, and it leaves a 3. So if you can make sense of that canceling, instead of doing all this mess with the fractions, you get to do this, which is way easier. So now we just have 2x and 10x for 12x equals 3, divide over the 12, x equals 3 over 12, and then that reduces down to the same 1/4 that I got last time. So those are both totally valid ways of doing it, and whichever makes better sense is probably the good one. Again, if you can get where you can go from here to right here, to me that's the easier math, but the canceling step is a little hard.